Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video. And today's video is about another interesting concept in electrical and electronics engineering. We're going to see problems on K-map. We're going to see 4 variable K-map problem for POS method, right? Uh, Before starting this video, I would recommend you people to go back and see the previous videos of K-map, where I have explained the structure of K-map, the rules and regulation that you have to follow for POS and SOP method. If you understand the rules and regulations of POS and SOP method, then you can able to solve the problems very easily, right? And today we will see a problem in POS method using 4 variable K-map, right? So this 4 variable K-map are very important questions where this can be asked in your part C. It can be it can be as 15 marks or 12 marks, right? So the very first thing you have to understand what is POS method. POS is nothing but product of sum, which means you will have sum and you have to product all those sums. That is POS method. And very first thing you have to understand here is it is opposite of SOP method, which means 0 represents non-complement form and 1 represents the complement form, right? And the very first step you have to solve in this problem is you have to find out what is the structure we have to use, right? So from here you can see here the question is given only A, so Y, right? Only Y. So what structure I have to use, whether it is 2 variable K-map, 3 variable K-map or 4 variable K-map, you can see these values. If this value is greater than 7 and if it is within 15, then it is 4 variable K-map. So the maximum value here is 15. So definitely we'll use 4 variable K-map. 4 variable K-map. B, this will be C and D. So which means 0, 0, 0, 1, right? And this will be 1, 0, and this will be 1, 1, correct? And here it will be 0, 0, 0, 1, 1, 0, 1, 1, correct? And now what you have to do, you have to find out the positions. What is the positions? This is 0, this is 1, this is 2, and this is 3, and this is 4, and this is 5, and this is 6, and this is 7, this is 8, and this is 9, and this is 10, this is 11, this is 12, and this is 13, and this is 14, and this is 15. Correct? Right? And now what you will do, you have to assign these variables, right? So for that, I already said for 0 means it is a non-complement form, correct? So this will be A, B, this will be A, B, correct? And this will be A and B bar, A and B bar, right? And this will be A bar, B bar, this will be A bar, B bar, and this will be A bar, B, right? And similarly, this one will be C bar, D bar, this will be, sorry, it will be C and D, C and D, because 0 is not complement form, correct? So it is C and D, and this will be C and D bar, this will be C bar and D bar, and this will be C bar and D, right? And now what we have to do, what is the next step? Whatever position they have given, for all those positions, you have to put 0. So 0, right? And then it is given as 2, so 0 here, and 4 it is 0, and 6 it is 0, 7 it is 0, 12 it is 0, and 14 it's 0, and 15 is 0. Correct? So you can see here 0, 2, 4, 6, 7, 12, 14 and 15. And remaining things we have to put it as 1. Correct? Now, how will I obtain the values here? Y is equal to, and how will you combine here? You have to combine. I already said the combination, this is very tricky problem where the combination can be done with the maximum values, right? First you have to look for 16, then you got to look for 8, and then look for 4, right? So here 4 is possible, correct? This 4 is possible. This 4 is possible, correct? Right? Now, so this 4 is possible. What is the values? So you see here is here, it is A, B bar, right? So here the common terms, it is these two terms. I read clearly here. The first term is A and B bar, and the second term is A bar, B bar, A bar, B bar. So the common A and A bar will get cancelled. So common bar is B bar, right? These two. And among these two, right, C bar is common, right? D and D bar will get cancelled. So it is C bar. So we'll write as B bar plus C bar, right? For these four, right? Another thing, what you can do is, you can see these four, you can combine these four. You can see here, these two, and as well as these two. Four. We have to give four preference, not two. Four preference. So we take these four corners, right? These two corners. So if we take these two corners, from these two you can see here A, B, and A, B bar. So the common is A plus among these two C D and C bar D. So D is common, right? C and C bar gets cancelled, so D is common. Correct? Right? And similarly, we can also combine these four. See this? These two and these two. Right? In that case, what you can do once again, these two terms. These two terms, A, B bar and as well as A bar, B bar. Right? So in that case, only B bar is common. Correct? Only B bar is common. Right? And among these two, right, these corners, C and C bar gets cancelled, so only B will be there. So this is the answer. Right? So we will check it out, the answer. So you can see here B plus B bar C bar, and you can see B bar C bar, and it is A plus B. Yes, we got A plus B, and then we got B bar D, right? And you can see B bar D. Right? So if you follow the procedure correctly, you can definitely get the problem correct, right? And what is the next step you have to do? You have to implement using logic gates, right? How will you implement logic gates here, right? We can follow the same method what I have explained before. What is that? I'll just erase some part of it so that we can implement the logic gates, right? You can follow the same procedure: A, B, C, and D. A, B, C, and D. Right? So you can see here it is B bar and C bar. So from B I'm taking it, I'm putting a NOT gate here, and then from C I'm putting a NOT gate here. So it will become B bar and C bar, and it will be a summation. So I use an OR gate. Similarly, A and D, right? It is still A and D. A and D, and again I'm using an OR gate, right? Because some summation, and then it is B bar, so it is AND gate, right? And then D directly. So I'll use another OR gate, and all these things will be combined as a NAND gate. I'll be combined as a NAND gate. correct? Right? So this is POS method, right? So whatever I explained, that is what solved here. So you can see they have taken these four and this four, right? And also this four. So from this you can obtain B plus C bar, B bar plus C bar, and for this green you can obtain B plus D, and for this blue you'll obtain A plus D, right? The same steps, whatever values they have given, right? We have to put it as 0, and for others, we have to put 1. And one important thing for POS method is 0 is considered as a non-complement form, and 1 is considered as a complement form, right? And for this expression, we are using the logic gates. You can draw very easily like what I have explained before, or else you can draw like this: A bar, B bar, C bar, like this. All these things will be combined in a OR gate. You have three OR gates, and you will combine that with an AND gate, right? So today, what we have seen is we have seen a problem for POS method for K-map using a four variable K-map, right? I believe this video will be very useful for you. Thank you, my dear students.